What happens now in soccer? In soccer, again, we can see that reporting again on top the equation for the top runner, 1.15 divided by time plus 27. This equation can be applied to the average runner. How? Well, very simple. We can use the first term, 1,147 is the maximal anaerobic capacity. It can be replaced by the actual value for an average soccer player, which is not very far from that value indeed. And the 27 must be replaced with the maximal oxygen consumption of an average player, which is substantially less than 27 watt per kilos. In this case, we have again the equation that you have seen before, and the area shaded in gray is the area wherein the function is a hyperbolic function. And you see what happens as you have seen before. But if we now apply, again, this is the same relationship for world record holders, men, and if we take an average soccer player with a very good VO2 max of 19 watts per kilogram, 19 watts per kilogram correspond to about 55 milliliter of oxygen per kilogram and per minute above resting, so it is a substantially reasonable value. And the 1,147 joule per kilo body mass anaerobic capacity is reduced a little bit, but not so much after all, because these are young athletes with good muscles, and so their maximal amount of energy that can be derived from their anaerobic source, phosphocreatine depletion, and lactic acid production is not substantially different than that of a top athlete. But let's consider a lesser endowed athlete with a VO2 max. Let's assume he has the same maximal anaerobic capacity, 1.1 kilojoule per kilogram, and whose VO2 max is not 19 but 15 watt per kilogram, which correspond to a VO2 max of 45, a little bit less, 43 point something milliliter of oxygen per kilogram and per minute. So this and the two. The red curve again is the curve applied for world record holders, and the two curves for player A and player B are the maximal average power that these two athletes could sustain for a time that corresponds more or less to a whole match duration, 5,400 seconds.